Hello, welcome back to Learning with Ms. H. Today we're going to be looking at our erosion and soil lesson. So go into the modules, find today's date, click on erosion and soil, and this is your lesson for the day. There's a bellwork assignment here for you in the starter section. Do this in your notebooks. You're just going to answer these review questions about rocks and the rock cycle. So just do that in your notebooks, and then for the lesson, we're going to take notes and do an assignment. So I'm going to have you guys go ahead and pause the video, gather your supplies, do your bell work, and then rejoin me here when you're done. All right, welcome back. I'm going to go through the homework assignment today very quickly first, and then we will get into the notes so that those of you that want to do notes on your own can do so and have the homework already kind of in the back of your mind. And those of you that want to go through the notes with me, you can do that as well. So you're going to come down here to the assignment section, click on the weathering and soil questions. This is a set of 11 questions. They're true, false, multiple choice, multiple select. They all come directly out of the notes, and there are 11 questions total. Some of these are going to be matching. Remember, on the matching questions, you need to get them all right to get the total points here. So make sure that you have selected the correct answer for each of them. This is one of the NADA quizzes, so if you get done with it and you're not happy with your score, just go ahead and take it again. You can take these, remember, as many times as you need to until you get a grade that you are satisfied with. My satisfactory grade for you is 100%. If yours is less than that, you can stop wherever you're happy with your grade. If you are a take it on your own person, you can go ahead and stop the video at this point and start taking notes on your own. If you are going to take notes with me, go ahead and gather your supplies and we will jump in. All right, so today we are taking a look at erosion and soil. We're going to look at several different types of erosion. We're going to start off looking at the difference between weathering and erosion, move into the different types of erosion, and then we're going to talk about the soil layers and why they're important, how to read them, that kind of thing. So let's go ahead and jump in. This is an image of the Grand Canyon. This is Horseshoe Bend. Grand Canyon, remember, was formed by weathering and erosion from the Colorado River. So it ate away at this rock and weathered it down to this point. And as it eats away at the rock through weathering, erosion from the water pulling the soils or the sediments away causes this canyon to form. So you break it away or dissolve it away with the water, and then you move it away with the water. So weathering, breaking it, dissolving it, erosion, moving it out with the water. So this first slide is going to be comparing the two. Weathering, remember, is breaking down materials. Erosion is moving that sediment away. So breaking materials, rocks into sediment, weathering, moving that sediment, erosion. Two types of weathering, mechanical and chemical. Chemical is dissolving it, turning it into something else. Mechanical is just breaking it apart into smaller pieces that are the same. The image on the left here is an image that I recently took at a place called Skull Rock. It is at Joshua Tree National Park in California, Southern California. And it's called Skull Rock because of the weathering pattern from the wind. If you take a look at the rock in the background here, if you use your imagination, it kind of does look like a skull. You've got an elongated head here, but it kind of does look like a skull. You have two eyes and a nose. So that's how it got its name, Skull Rock. And the reason it has this weathering pattern is because of all these rocks in front of it. When the wind blows across the rocks in front of it, that's where it hits Skull Rock, is in those locations to kind of chip away at the particles in those locations to make those indentations. So it's kind of a unique place. It's kind of a cool place to see, but that is mechanical weathering from the wind causing that at Skull Rock. On the right-hand side, I have an image from Death Valley that I took during my recent PD trip that I took there. So the image from Death Valley on the right is the alluvial fans. And what an alluvial fan is, I've got them pointed out here in arrows. This is basically runoff from the mountains coming down. You've got a really flat playa down here, and a playa, Playa, is an area where it's super flat and it's super dry and arid, and it just sucks in the moisture. So when it rains here, you'll get flash flooding, but then almost immediately all of that water from the flash flood gets sucked into the soil and dries it up again very, very quickly. It doesn't really stand, you don't have standing water for long periods of time because it's so dry there. So what happens is you have runoff from the mountains coming down into this playa, and as it gets down here, anytime you come from a canyon, which is a really narrow space, into an open flat land like this playa here, which is a wide space, you go from being really constricted to all of a sudden having all of this open space. So the water is going to fan out and spread out as soon as it gets through that opening of the canyon into the playa. And what happens is all of that sediment that it's carrying then gets deposited here at the base of the mountain, because as the water is rushing through the mountains, it gets its speed from being pulled down the mountain and being constricted. Once it spreads out, it slows down a little bit. And as it slows, it drops all of that sediment down into these raised areas. These are angled. Obviously not as much as the mountains, but if you have like the mountains and an angle like this pencil is here, this is your mountains, then you have your flat land underneath. So the alluvial fan is going to be kind of tilted and take up this space here where they meet and kind of smooth out the angle there. The same thing happens at a river delta. Alluvial fans happen on land. When a river opens up onto flat land, you get an alluvial fan. When the river opens up into another body of water, a larger body of water, you get a delta. And we're going to take a look at deltas in an upcoming slide. 4 types of erosion can happen. You can have water, wind, gravity, or glaciers. And we're going to talk about each of these. Water, wind, and glaciers actually cause weathering and erosion both. So they can each weather the rock and move the rock at the same time. So let's jump in and take a look at those. Remember, when we're going through these slides, you can always pause the video if you need more time in between. Pause the video, finish the slide you're on, restart the video. So this is a quick animation of how the alluvial fan forms. There's not a voiceover on it. It has these little cards here that talk you through it. But basically you have this area up here on the top of the video are your mountains, and the openings are your canyons. So the water is going to flow out through the canyons into this open flat area here, which is going to form your alluvial fan. Just watch the first 45, 48-ish seconds of this video. The rest of it's credits to see how an alluvial fan forms. And remember, deltas are going to form the same way, but in water. So pause me, watch the first 47-ish seconds of this, and then come back. All right, erosion. Erosion, remember, is the moving of sediment. You don't need to write down this black part in the middle because we're going to talk about each of these types, and you already wrote them down. Ocean currents and waves are part of water erosion. Then you have wind erosion, you have glaciers up here, and then we're also going to talk about gravity very briefly. So erosion is moving sediment, and then you also need to know down here, this bottom blue, deposition. Deposition means you are depositing the sediment, so you're setting it down somewhere new. So the way this process works is weathering breaks it, erosion moves it, deposition drops it. So break, move, drop. Weather, erosion, deposition. So weathering breaks it, erosion moves it, deposition drops it. There is a test question where you are going to need to put those in order. So the first type of erosion is erosion by water. So when water moves, it's going to take those particles along with it. It can be really destructive. It can move massive amounts of sediment at a time. It can change the course of a riverbed as the sediment gets deposited along the river. It can change how the river or where the river is flowing through. And then it can form those deltas at the end when it opens up into a wider body of water. This video is of what we call a stream table, where it's basically a table filled with sand. He's going to make a river bed, just a straight line riverbed on the table, and then you're going to watch as that river moves and flows and changes shape, and you can see how the sediments are deposited in different areas, changing how the river flows through it, and then eventually forming the delta at the bottom. So go ahead and pause me, watch this animation, but it talks you through what's going on in the subtitles at the bottom as well. All right, so hopefully you watched that on how a delta is formed. Remember, deltas form when the flowing water opens into a larger body of water. Alluvial fans when it happens on land. And next slide. Here we go. This is another video about how deltas form. This one is actually going to give you a connection between earth science, geography, and anthropology. So how humans impact delta formation, how we use the land around delta formations, how the geography affects delta formations, and then how the delta formations affect humans. It's going to show several different deltas around the globe in this video, and then it's going to talk specifically about the one in New Orleans at the mouth of the Mississippi River. If you think about New Orleans, it is actually located below sea level, which is why it floods so easily. They have all those levees built, and it's affecting the delta down there and causing land to erode away more rapidly. So we've really had kind of a negative impact on the environment down there, and that's partly why they have so many issues with flooding. But watch this video so you can kind of see how we use the areas, how we affect the areas, and those areas affect us. We're next going to talk about wind erosion. So wind erosion is when wind picks up particles or sediments and moves them away. And what you're looking at here, the picture on the left is one of the large windstorms that we had while we were out in Death Valley. This is that flat basin at the bottom of the mountains. It was covered with sand and salt, and all of this cloud here, that is actually dust getting kicked up by the strong wind, and it's getting moved to a new location. And one of the unique things about Death Valley is there are a couple of places where the winds meet. You're surrounded by mountains on both sides, and that causes the wind patterns to be such that they meet up in kind of almost a vortex in specific regions of the valley, and they create sand dunes. Similar things happen in the Mojave Desert, which is the image on the lower right here. This is the Kelso sand dunes in the Mojave Desert. They are 600 feet high. I did not climb them. It was pretty tough to walk out there because the sand was so loose. So I had to get out my brace and the cane. I was able to get out there a little ways with the cane going, but it's very loose sand piled up 600 feet high on these tall dunes here. And as you get more winds and strong winds through the area, all of this sand and sediment that gets kicked up by those winds ends up collecting in those regions where the dunes are. So there's two areas in Death Valley that have sand dunes, and there's this one giant area here in the Mojave that has sand dunes from the same thing. And these are constantly being reshaped and reformed, and they'll look different every time you visit them, because as the winds move, they change shape. So this generally happens in arid or coastal regions, places where it's dry. They don't get a lot of rain. There's not a lot of plant life to hold the soil in place. In the case of this windstorm in Death Valley on the right over here, there's no plants out there on this valley floor here. There are no plants there at all. So there's nothing holding it there. At least on the right here, you have a few plants, just not enough to keep all of that in place still. And again, these really strong winds can cause a lot of erosion. They can even cause really large objects to move.
This image is of a boulder in what's known as the Racetrack Playa in Death Valley National Park. It's known as the racetrack because these boulders, sometimes basketball-sized and larger, seem to move across the flat playa with no assistance from anything. Researchers have been looking into this for a long time, and as you can see in the information from Death Valley National Park's ranger station display, they believe now that it's caused by possibly sheets of ice moving across the playa. So how does that happen? You have the large flat area, it's surrounded by canyon walls. In the wintertime, you get runoff coming down from the canyon, snowmelt coming down from the canyon, and these boulders come down with it. So when they land on the playa, we get these really large winds. The boulders are on the playa, you get ponding from the runoff, you get ice surrounding the boulder here, and then as the ice moves across the surface, so do the boulders, causing these tracks. The ice is super thin, floating on the layer of water underneath from all of that runoff. It's very, very cold at night, which causes the ice to form. It moves across in large sheets and then melts away again. All of that liquid gets absorbed into the dry playa bed, leaving no trace of it behind other than these trails behind the rocks. Again, this is ongoing research. Nobody has actually witnessed this as it was happening, but there is some evidence from time-lapse photos and measurements of various instruments that were left in the area by experimenters.
Erosion by gravity. For this one, the first two bullet points here are really the two most important. Anytime that soil or rock is pulled down towards the earth, that is moved. It's being moved by the force of gravity. So when a rock falls off of a cliff, or in the case of the image on the right here from Washington State's Department of Transportation, they had a really heavy rain, and then the mud on the mountain was pulled down from the mountain and is covering this roadway here. So direct impact of gravity causing gravitational erosion, mudslides, landslides, slumps. Generally, those are going to be in regions with high hills, mountains, steep cliffs, those kinds of things, and gravity is just pulling that stuff down towards the earth. In areas where there are more plains type regions, like we have around here in the Midwest, you could have chemical weathering causing those caves to form. It dissolves the rock away underneath the surface, causing those caves, and then gravity pulls the roof of the cave down, causing the sinkhole. You can also have indirect gravitational erosion through runoff, rain, glaciers moving, but we consider those to be water erosion or glacier erosion instead of gravitational. So the first two bullet points here are the two you need. All right, erosion from glaciers. You should have information about abrasions already in your weathering notes, and glaciers are another one of those items that can cause weathering and erosion, and both of these, abrasion and plucking, can cause both weathering and erosion. So a glacier is a giant sheet of ice, and it can move based on the climate, how much moisture you have, how hot or cold it is going to determine the size of the glacier. So it can expand and contract based on the climate of the region. As it moves, it collects all of the debris from materials that are underneath it. So it's not just a clean sheet of ice. It's very dirty and rough and sandpapery underneath there. And so as it scrapes across the surface, it is going to cause these abrasions, which is basically scraping off little bits and pieces of sediments, which is weathering, and then those pieces get collected into the glacier, and as the glacier expands or contracts, it moves and it carries that with it, which is the erosion. Same thing happens with plucking, except instead of being smaller bits and particles and sediments, it's going to be larger chunks, whole rocks, bigger pieces. And those are going to be because of cracks that are already formed in the bedrock underneath the glacier. And as the glacier moves, it takes off whole chunks of rock. Entire pieces of rock can be broken off and carried away. And again, breaking it off is weathering, carrying it away is erosion. All right, we're going to focus in on soil right now. You're going to see what soil is, how it relates to bedrock, and then learn about the layers of the soil. So basically, soil is just the loose sediments and particles that are on the surface of Earth's crust. They're going to be covering up all of the dead, decaying organic matter. So plants and animals that have died, organisms that have died, are going to be below the soil. If that top layer of soil is the same as the parent bedrock, the bottom layer of soil, we call it residual soil. Most of our parent bedrock is going to be granite based. Again, if you think back to when we talked about rocks and minerals, and when we talked about composition of the continents versus the ocean is made of basalt, continents are made of granite. So if your parent bedrock down here on the bottom layer is the same as your sediments up here on the top layer in the soil, we call it residual soil. And then your decaying organic matter is going to be down here below it. The very top layer here that has all of the living matter, the living organisms, we call the organic matter humus or leaf litter. That's all going to be up here on top of the soil. And you can see that in this drawing of soil layers. And it lists out each layer of the soil and what it's called. The important ones are going to be the bedrock down here at the bottom, the surface soil, layer A, and then up here at the top you have your live organic matter. So this is going to be your leaf litter and your humus. That is the O layer for organic, and you need to be aware of this O layer and what it is. That's going to be on the test. So know your soil layers. Once you've sketched this into your notebooks and you've put a little star or a circle or something around the O layer for the organic layer, or the O horizon is it's sometimes called, that is your humus and leaf litter, the O layer, organic layer. I've said it several times. It's going to be on the test. Make sure you know it. Come here to this video. It's a quick 5-minute video talking to you again, reviewing weathering, erosion, deposition, just as a quick recap of everything that we've talked about in the notes today. Once you're done with that, go ahead and work on your homework assignment, and then you'll be done for the day. We'll see you next time.